All right, we're going to be talking about probability today, an introduction to probability at that. So let's start with our learning goals. We want to be able to find the theoretical probability of an event and apply the fundamental counting principle. So with that, I think we need to start with some vocabulary. So back in class, we'll be discussing these, but notice on the left I have some words, and on the right I have their definitions. So we want to be able to define what a compound event is, what experimental probability is, systematic lists, theoretical probability, and a tree diagram. So in the reading that I gave you prior to listening this, some of those should be familiar with you. If not, go back and reread, and you should be able to match those up for us, and we will do a double check in class to make sure you have the correct words with the definitions. Also, when we talk about experimental versus theoretical probability, remember, experimental is based on the results of an experiment, exactly what it describes. It compares the number of favorable outcomes that occur during the experiment to the total number of trials conducted. If a large number of trials are completed, then the experimental probability will approximate the theoretical probability. Results can differ. Experiment means exactly that. What you are getting as favorable outcomes over the total. Theoretical, though, is determined by analyzing the situation. It compares the number of favorable outcomes to the number of possible outcomes, and the results do not differ. It's always, always, always that way. So experimental, theoretical. Over the long run, experimental should match theoretical. Most of what we're doing will be the theoretical type. Also, some other words. Typically, we like to call something an experiment. We like to call something else a trial. We can do it randomly. We have an event, and we have sample space. So again, some more words that you should be able to combine with their definitions based on your reading. And we will double check those in class. Experimental probability is going to be written as the notation P of the event, and sometimes it's just an alphabetical letter. So if I want the probability of getting odds on a dice, I would put P of O. The number of times the event occurs over the total number of trials that have taken place. So you'd be doing a certain number of rolls, and you would be counting how many would be odd, for example. If it's a fair game, is a game in which the theoretical probability of each player winning is equally likely. Theoretical probability of an event, the number of favorable outcomes to the number of possible outcomes in the sample. So in the experimental probability, getting odds might not have been the same as when we do it with theoretically. Theoretically, odds on a dice, rolling odds, you think, okay, you have the numbers 1, 2, 3, 4, 5, 6, and exactly 3 of them are odds, so you're thinking 3 out of the total 6, 3 out of 6 is 1/2, so it should be theoretical probability of 1/2. When you actually roll the dice, in X number of trials, it might not come out to be 1/2. That's the difference of the two, experimental versus theoretical. Fundamental counting principle, a third piece. If there are m ways that one event can occur and n ways that another event can occur, then there are m times n ways that both events occur. There might be 3 ways for you to walk home and 2 ways to walk from your house to the library. How many possible ways are there to walk from your house to the library? 3 times 2, 6 possible ways. Compound events, when we talk about big mathematical idea, a compound event or situation is one where 2 or more simple events are combined, such as rolling a number cube and spinning a spinner. So number cubes are referred to as dice, die. One method of finding the number of possible outcomes in a compound event is to systematically list all possibilities in a table and then count them. You can multiply the number of possible outcomes for each of the independent events as well. Compound, two or more. So as an example, when we talk about tree diagrams, what's going to happen here is you can see in this first question that you're at a carnival. One of the carnival games asks you to choose, pick a door, and then pick a curtain behind that door. There are 3 doors, 4 curtains behind each door. How many choices are possible for the player? So this representation here we'd like to call the tree diagram. You would start with 1, 2, 3 doors. From each of those doors, there's a choice of 4 curtains. So if we say what different ways can we choose, you're thinking, okay, one could be with A, one B, one C, one D, then door 2, A, B, C, D. So there's really 12 possibilities here. 3 times 4, or 12. Now, if we go and check these, and we say our answer is 12, you can see that good job. That is your first guess, and it was correct. Another example of the same thing, and you can work through these on your own. The 4 aces are removed from a deck of cards. A coin is tossed. One of the aces is chosen. What's the probability of getting heads on a coin and an ace of hearts? So you're going to have to remember, and again, if you want to see the tree diagram, what they took out, what was left in and included, if you want to see the tree diagram, you can get a picture or you could draw your own. Okay, so those are the choices. So you could play with that just to double check some situations. Okay, now back to our example here. We are going to do in class a game called Race to 10. I'll explain that when we get to class. But now that we talked about some of these types of probabilities, let's check. Find the probability of randomly selecting an orange marble in one draw from a jar containing 8 blue, 5 red, 2 orange marbles. So right away you're going to probably do an arithmetic problem and say, hey, how many marbles do I have? And they told you. And you're going to do one draw. So we know we have a total of 15 marbles. Now the question is, what are we going to select? It says find the probability of randomly selecting an orange marble. Well, there are only 2 marbles in there, so you should be thinking 2 out of the 15. 2 out of 15 could be also expressed as 13.3% if you change that to a decimal and from there to a percent. Now, next one. Jana sits down to dinner at some time between 6 p.m. and 7 p.m. Assuming that all the times are equally likely, find the probability she will sit down to dinner during each given interval. So choice A, 6:10 to 6:30. Most people say that's a 20-minute period, and 20 minutes out of the total hour that we're talking about for dinner. So 20 out of the hour, 20 out of the total. Again, you can express it as a fraction in lowest terms, which would be the 1/3, or the 33 1/3%. Part B, 64 or 6:45 and 6:55. Now we're talking, is she going to sit down? And it's only a 10-minute interval. So a 10-minute interval out of, again, the 60 minutes in an hour. Reduce, 1/6, divide, 16.6 repeating, or 0.7 to the nearest tenth. Amy must choose a password for her voicemail system. She cannot use the letters A and Z or the digits 0 and 9. So you can see the choices down below. Each letter or number may be used more than once. Oh, how many possible passwords are there if the password is supposed to be 3 letters followed by 3 digits? So some people might envision drawing saying, hey, my password has to be 3 letters and then 3 digits. And it does say we can repeat, it just says we can't have certain ones. So we know in the alphabetical characters there are 26 letters in the alphabet, but take away the 2 they tell us we can't use, that means there are 24 letter choices. And then for the second option, again 24, because we can repeat. and the third one 24. And then the digits 0 through 9 are 10 digits, but if we take those two out, we're at 8. So I could have an 8, an 8, and an 8. So again, this is that combination of so many ways of doing something. So if I have 24 to get the first one, 24 to get the second one, and we go right on down to the 6, you better be thinking that's going to be a fairly big number. And there's the math as well as the answer. Lastly, 3 numbers from 0 to 9 are randomly selected. Find the probability the first number selected is 5 or 7, the second number is a 2, the third number is a 3 or a 9. So when we say we're going to select some numbers, and we've got 3, so start thinking, what's the possibilities? 0 through 9, the probability the first number selected is a 5 or a 7. Well, 5 or 7 is 2 out of the 9 originally. So the probability of getting that first digit is 2 ninths. Probability of the second number being a 2, well, there's only one 2, so that would be 1/9. And the third number is a 3 or a 9. Again, there's 2 possibilities of that. So if you look at those combinations, do your math, fraction in lowest terms, or change to a decimal. Whoops, I said 9. 10, obviously. 0 through 9. Big mistake there. But otherwise, we had the right idea. And some of you probably would have caught it. So 10, 10. There's 10 total out of 0 through 9. And so I'm going back to our answer choice. 2, 1, 1. We're looking at 2 times 1 times 2. All the fractions multiplied out is 4. 10 times 10 times 10 is 1,000. 4 1,000s, lowest terms, or as a decimal, gives you your probability. So those types of counting problems are what we're looking at today. And we'll do a couple other activities with things in class. But you should have enough information and double check the vocabulary to bring with you to class.